Hello, everybody, and welcome to math class. Glad you could join us. Here's the stuff you need right over there. Something to write on, something to write with. Don't need rulers today because we're not focusing on our number lines today. We are going to be doing comparing fractions using equivalence of 1. We did a bunch of practice last week thinking about how we use fractional equivalence of 1, 2 halves, 3/3, 4/4, 5/5, etc., in order to change the denominator of our fractions, change the size of the piece without changing the value, the overall total value of our fractions. And we're going to use that skill today when we're comparing two fractions. Here's our talking points or teaching points down here. I can accurately create equivalent fractions by equivalence of 1, by using equivalence of 1. I forgot a word in there, but that's fine. I can use the greater than, less than symbol to compare quantities. Let's start with just a refresher on these two words, numerator and denominator. So the top of our fraction, that's called the numerator. That's going to be how many pieces we're dealing with, right? If we have 2/3, for instance, as a fraction, we know we're dealing with 2 pieces. And our denominator tells us the size of the piece in relation to the whole. So if we have 2/3, we know that we have 2 pieces, and each piece has the value of 1/3 because of our denominator. Now, let's start with what we know with fractions before we get into comparing them. For instance, let's start with something like this. Which is greater? 2/3 or 1/3? I bet you're saying to yourself right now, obviously, Mr. Taco, it's 2/3 is the greater quantity. And you'd be correct, right? If we were to draw 2 fractions bars equal to 1, divide them both into 3 equal pieces, we can very clearly see that our 2/3 is greater than 1/3. There's more pieces, right? If you have 2 pieces of birthday cake, I have 1 piece of birthday cake, and our birthday cakes were the same size, then you obviously have more cake, right? So what we can know and what we can say as a rule is if the denominators are the same, if the pieces that we're working with are all the same size, whichever fraction has more pieces is going to have a greater value. That's always going to be true, okay? If we're, whether it's 1/3, 4ths, 5ths, 10ths, 100ths, right? Whichever fraction has more, whichever fraction has a greater numerator is going to be the greater fraction, okay? So denominator is the same. Whichever has the greater numerator is going to be the greater fraction. Okay? What about something like this? Let me grab my eraser here. What if you had something like, which is greater, 3/4 or 3/5? This one can be a little trickier because we've got the same number of pieces. If you've got 3 pieces, I have 3 pieces, aren't these equal? No. And let me show you why. If we were to draw these 2 equal fraction bars out, both with a value of 1, I'm going to divide this top one into 4ths. I'm going to divide the bottom one into 5ths. And then we'll shade in 3 pieces of each. which fraction is greater? 3/4 or 3/5? Right, it's 3/4 is the greater value. Okay, if we have the same number of pieces, but my pieces, the size of my pieces are larger because I divided this one into fewer pieces, then I'm going to have more, right? If I cut my pizza into 4 pieces and then eat 3 of them, you cut your pizza into 5 pieces and then you eat 3 of them, I will have eaten more pizza, right? Same thing if I have 3 pieces from a large pizza, you have 3 pieces from a small pizza. Since my pieces are bigger, I have more pizza, even though we had the same number of slices. There's a famous joke from Yogi Berra. He was a former baseball player and all-around kind of funny guy, and he's known for these little quippy quips, but he once said allegedly, he once said to a waiter at a pizza place, you better cut my pizza into 4 pieces because I'm not hungry enough to eat 6. Do we get the joke? Right? He's eating the same number of pizza. He's eating the same amount of pizza. It's just bigger pieces. So we have a couple of rules here, and I'm going to write them out. Where's my eraser again? There you are. So if the denominators are the same, the larger numerator is the greater fraction. Okay, if the denominators are the same, the larger numerator is the greater fraction. Right? 4/6 is less than 5/6, as an example. If the numerators are the same, here's the tricky part, right? Because actually it's the smaller digit for the denominators, or the smaller number, but a smaller number in the denominator actually means a bigger piece. So the smaller denominator is the greater fraction. Right? 4/8 is going to be less than 4/7, because a 1/7 is a bigger piece than an 1/8. Okay? So these are the two rules we're going to use, and we can use these 2 rules to help us compare any 2 fractions with our greater than, less than, or equal than sign, even if, to start with, our numerators and our denominators don't match. So it can be really tough just right off the top of your head to compare those fractions. So what we're going to do is we're going to use our equivalence of 1 to create a situation where either the denominators are the same and we can compare the numerators, or the numerators are the same and we can compare the denominators. Let's practice a couple. Okay, so hold on, I can do this. I'll leave our rules up here. Ta-da! And I'm going to scoot the board over just a little bit. There we go. I can take our science word wall down because we don't need it till Thursday. Now we've got space. All right. So if we had something like, let's say, 3/5 and 6/7. Now, our numerators aren't the same, And our denominators aren't the same. So it's tough to compare these straight away. But remember, we have our secret weapon. We have our equivalence of 1. If I multiply or divide these fractions, either of these fractions, by an equivalent of 1, 2 halves, 3/3, 4/4, 5/5, etc., till the cows come home, I can change this fraction without changing its value. Okay? I can, essentially what I'm doing here is I could be cutting the same amount of pizza into smaller slices, or kind of sticking our slices of pizza together into bigger slices, but without changing the amount of pizza that we're talking about. Okay? So looking at 3/5 and 6/7, what I want to look for is, are the numerators like in the same multiplication family? 5 and 7, no, those are actually both primes, but what about 3 and 6? I know that 3 times 2 equals 6. So what have I used? 2 halves. That's an equivalent of 1, and I can multiply 3/5 times 2 halves, and it doesn't change the value of our 3/5. So let's do that. Times 2 halves, and I'm going to put it on this side. So 2 times 3 is 6. So there's our 6, our numerators match. 2 times 5 is 10. So now we know 6/10 and 3/5 are equivalent fractions, which means now we can compare whether 6/10 or 6/7 are greater. So now let's go back to our rules here. If our numerators are the same, they're both 6s, we have 6 pieces, but which is the bigger piece? Is a 7th the larger piece, or is a 10th the larger piece? Right, our 7th is the larger piece. If we divide 1 into 7 equal pieces, they're going to be larger than if we divide 1 into 10 equal pieces. So our 6/7 is greater. Okay? Make sense? Let's try another one. Let's try this one. Let's try 3/4 or 10/12. 3/4 or 10/12. Is there a way to make either the numerators using multiplication, either a way to make the numerators match or make the denominators match? I'm looking down here already to the denominators because I see 4 and 12. I know that 12 is a multiple of 4. So I can use that to my advantage. 4 times what is 12? 4, 8, 12. 3. 4 times 3 is 12. And remember, to keep it an equivalent of 1, I've also got to multiply by 3 on top. I've got to use 3/3. If I multiply by 1/3, it changes the value of my fraction. Okay, I'm not dealing with the same amount of pizza or the same amount of cake or whatever analogy you want to use. Okay, so 3/4 times 3/3. That's going to get me my 12ths in the denominator, so I can compare them. And then 3 times 3 is what? 3, 6, 9. So now we have what is greater, 9/12 or 10/12. And at that point, it becomes a little simpler, right? The size of our piece is the same, so all we need to know, what has more? Where's our 10/12 has more? Make sense? Every once in a while, I'll give you one that I'm pretty sure I didn't put on the exit ticket, but you might encounter it later. So this is just kind of a preview. So just watch this one. What if you had something like 5/7 or 3/5. Right? You're like, well, 5 and 3 aren't in the same multiplication family, and neither are 7 and 5, so what the heck do I do now? What you can do is actually use our denominators and multiply them by each other. So I'm looking over here, because I know that 7 times 5 is the same as 5 times 7. That's going to get me 35 in both cases, right? So I can do 7 times 5/5, and our 3/5 times 7/7. This is kind of next level, and we're going to build up to this. So don't, if this is confusing now, don't sweat it, okay? But 7 times 5 is 35, and 5 times 5 is 25. And then over here, 5 times 7 is 35. 3 times 7 is 21. So now what we're doing, since we've used our equivalent fractions, we're comparing 25/35 to 21/35. Go back to our rule. Denominators are the same. The larger numerator is the greater fraction. 25 is greater than 21. Therefore, 25/35 is greater than 21/35. Okay? That's kind of a sneak preview of where we're going. Just for today, there's only going to be one fraction that you need to multiply by an equivalent of 1. I might have put a bonus one that requires you to do both. I don't remember. Try it. Let's go to our digital whiteboard and do a few more practice problems here. Ta-da! There's our first one. So let's think about this here. 3/8. Ava says that is what you do when you add fractions with uncommon denominators, right? Yes, and we'll get to that. Okay. This is actually basically the same process you'll do for adding and subtracting fractions with unlike denominators. If you can match up the denominators using multiplication, do it. Okay. So 3/8 or 6/12, which one is greater? Now, what's the fastest way to get us to a comparison? Because we want to be able to have either the numerators be the same or the denominators be the same. And I'm looking on top and I see our 3 and our 6 pretty closely related, right? You could either multiply that 3 times 2 to get 6, or you could divide that 6 by 2 to get 3. I'm going to do it the multiplication way first. Then I'll show you the divide way. So if we're doing 3/8 times 2, because I want it to be 6, I want to have 6 in the numerator so I can compare them. And in order to keep the value, I've got to also multiply by 2 on the bottom. So now we're multiplying by 2/2, which is an equivalent of 1. So we're not changing the value. So 3 times 2, that's our 6. And then 8 times 2 is 16. So I have 6 pieces in both cases, 6/16 or 6/12. Is a 12th or a 16th the bigger piece? Yeah, our 12th is the bigger piece. Even though it's the smaller number, because we're cutting our 1 into fewer slices, each slice is bigger. So our 6/12 is going to be greater than 6/16. If we were doing it the division way, it would look something like this. 3/8 or 6/12. And we're going to divide, whoops, I'm going to put it on the other side. 6 divided by 2 to give us our 3 in the numerator so we can compare them. And then remember, got to be an equivalent of 1, so we're going to divide by 2 on the bottom as well. 6 divided by 2 equals 3. 12 divided by 2, or 2 times what is 12, is 6. So now we've got 3/6 or 3/8. And again, a sixth is bigger than an eighth. So 3/6 is greater than 3/8. Okay, let's try a couple more, and then we'll get to the exit ticket. And remember, if these are still a little bit tricky, come see us in the Zoom room. Okay, we're there working on stuff. We will personalize any math instruction that you want. If you want to work more long division, we can work more long division in the Zoom room. If you want to work more adding and subtracting fractions with like denominators, come do it. We'll give you some practice problems. We'll talk about it. Okay, so here we go. 5/6 or 2/3. Which one is greater? And how are we going to get either the numerators to match up or the denominators to match up? There are actually, if you really want to get technical, there are infinite ways you can do this. You just have to go really big to do it. So let's do it the simplest way here. Yeah, use our 3 to 6 connection again, right? 3 times 2. Whoop, let me change to the purple pen here. We're on the purple problem. 3 times 2 is 6. And remember, equivalence of 1. So you want to multiply by 2 halves. Okay. 3 times 2 is 6. 2 times 2 is 4. So now we're thinking 5/6 or 4/6. Pieces of the same size. So which one has more pieces? Exactly. Our 5/6 is greater. Now, could we do the division strategy here for this one? Let's run it back and look at it here. Could we make 5/6 bigger pieces? Well, the reason we can't, not technically, is take a look at our 5 up here in the numerator. I would have to divide 6 divided by 2 in order to get 3 on the denominator, so we can compare them. But does 5 divide by 2 evenly? No, we'd end up with like 2.5 which we don't put fractions in fractions. It's hard to read and is not very clear. Okay, so we don't put really put decimals in fractions either. It's kind of like crossing the streams in Ghostbusters. It'll like end the universe or something. Yeah, 5 can't be divided by 2 evenly, so in this case we want to use that multiplication strategy. Okay, and multiplying by 2 halves. Let's go to one more. Let's go to our green problem. 7/9 or 2/3. I'll move this down slightly. There we go. I was told I'm blocking, my face is blocking a bit of the equation because I'm in the top corner. And my face is far less interesting than math, so let's focus on the math and not my face. Okay. Excuse me, I got the hiccups. What are we going to do here? Do 2 and 7, are 2 and 7 in the same multiplication family? Not really, no. It's like 2, 4, 6, 8. So we'd have to do both of them, huh? We'd have to multiply both of them to get the numerators the same. But what about our denominators? 3, 6, 9. There's our key. 3 times 3 is 9. And as an equivalent of 1, got to be 3/3 in this case. 3 times 3, that's our 9, and then 2 times 3 is 6. So which fraction is greater, 7/9 or 6/9? Now that we've determined that 6/9 is equivalent to 2/3. And yeah, we can see if the pieces are the same size, our denominators match. Whichever one has the greater number of pieces, in this case 7, that gets our alligator mouth there, because 7/9 is greater than 6/9. All right, everybody. I hope this was informative. Again, I do want to put some concerns at ease here. If this is still a little bit confusing, that's okay. We really just kind of started working on this stuff. And if we got it immediately, it'd be too easy and we could move on to something else, right? So we want to work this out and we want to work through it. The best way to do that is jump in the Zoom room in a few minutes, okay? Do some practice problems with us. We've been getting like 5, 6 people in our math small groups every day. I'd love there to be more like 8 to 10, right? Because I know there are people out there that need help. It's just up to you to get it in this distance learning environment. All right, take care. I don't think I put a secret word in the exit ticket today. If I did put a secret word in the exit ticket today, the secret word is going to be cupcake. Because why not? So if you need a secret word, cupcake is your secret word. I hope to see you in the Zoom room for math support and feedback. If not, turn in that exit ticket, have a good lunch, and we will see you back here for writing at 12:30. Cheers.